Mr. Abbott, I'd like to welcome you to another Boring Science Explanation, or BSE. This one happens to be on phases of the moon diagram. Now, when you look at this diagram, first of all, it's impossible. There are not 8 moons that are simultaneously orbiting the Earth. This is a model that's showing you some aspects of the Earth's moon system to help you understand why and how we see the phases. Now, the first thing that you have to know is that the cycle, or the period for phases of the moon, the phases takes 29 and a half days. That would be for a full cycle from full moon to full moon, or new moon to new moon. Obviously, one of the things that this model is showing is that the moon is revolving or orbiting around the Earth. And if they ask you why we see phases of the moon, you should know that it's caused by the revolution of the moon around the Earth. The revolution only takes 27.3 days, and honestly, that's something that you can find on the Earth Science reference tables. Now, this diagram sometimes is called a bird's eye view, but it's looking from space. And whenever you're looking at this diagram, you can see that 50% of the moon is illuminated. No matter what position, 50% of the moon, as well as 50% of the Earth, is being illuminated by the sun's rays. That doesn't mean that we can always see the 50% that's illuminated. Now, I always think it's a good idea to locate the sun's rays. If they don't draw in the sun's rays coming from one side, you can tell which side the sun's rays are coming from based on which side of the moon and which side of the Earth is lit. Now, the easiest phase to start with is always the new moon, and the new moon is going to be nearest the sun's rays. So this point, position 1, is going to be the new moon. So up here, we're going to say new moon. Now, we're not in space, we are on the planet, so you can draw yourself in as an observer underneath. The easiest way to look at this is to rotate it 90 degrees so that you have yourself as an observer, and as an observer on Earth, you're only able to see what's inside the orbit line. So for this observer, when he looks up, everything facing him is not illuminated. So when you're looking at the new moon, it's daytime, but you don't see any of the moon's surface being illuminated. The half of the moon that's facing the Earth is dark. So in this diagram, number 1 is definitely the new moon. It's 0% illuminated, and to an observer on Earth, you would see it completely dark. Okay, there's no visible portion of the moon illuminated. Now, if I go on the other side, the full moon is going to be far. So if you remember, new is near, full is far. When the moon is in the opposite side, or in the opposite direction of the sun's rays, when you turn around, now for this observer looking up, all of the moon facing the Earth is illuminated. So position number 5 here is going to be our full moon, and the full moon represents 100% illumination. So we're going to say that the light represents what's illuminated, and we're just going to leave 5 the way it is. Now, 2 key terms that you need to understand for the phases are waxing and waning. A waxing phase means that it grows more illuminated. It's becoming brighter each night. Waning means that the illumination decreases. So waxing means growing, waning means diminishing. It's pretty easy to tell whether you have a waxing phase or a waning phase. If it's a waxing phase, then the edge that's completely illuminated, the circular edge, circular illumination, is going to be on the right. When it's waning, that circular edge, oops, a little misspelling there, sorry. All right, so when it's waning, the circular edge of illumination is going to be on the left. You wax on and then you wane off. All right, so waxing phases are anything from the new to the full. Waning, it's about 2 weeks. Waning phases are anything from the full back to the new. So on our diagram, when you're looking at this, from 1 to 5, all of these would be considered waxing. They're going to grow larger each night. And 5 back to 1 are going to be your waning phases. Now, there's a definite pattern or sequence to this. If you look up at number 2, okay, for an observer on the Earth, there's going to be a small little illumination on the right. Okay, when there's less than 50% illumination, that's called a crescent. So for number 2, this person's going to look up. On the right-hand side is the illumination. So diagram number 2 is going to look something like this. There's going to be a thin little sliver of illumination, and the remainder of the moon is not illuminated. So when you see the light edge, the right edge lit, that's waxing, but this would be considered a waxing crescent. You go to diagram 3. For the observer looking up on diagram 3, it's still the right edge where the illumination is, so it's still waxing, but now 50% facing the Earth is light, 50% is dark. So the terminator is going to appear straight up and down on the moon, and we're going to see that the right half of the moon is illuminated. You might want to call this a half moon, but that's not the correct term. This would be called the waxing quarter. Frequently, this is going to be, it's 25% of the surface of the moon, but it's actually a quarter phase is 50% illumination. So the waxing crescent is between 0 and 50. Okay, the waxing quarter, or sometimes they call it the first quarter, is going to be exactly 50% illuminated. That phase will last for 1 day. Now, position 4 is still a waxing phase. If I rotate it and I look up from the perspective of Earth, it's still the right edge that's illuminated, but now substantially more than 50% is light. There's just a small fraction that's not lit on the left edge. So when I get to position 4, the diagram would look something like this. Each day you're seeing the moon a little bit later because each day the Earth has to rotate a little bit farther to see the moon. So this would be a waxing gibbous. So a gibbous is greater than 50 but less than 100. So it's new moon, waxing crescent, first quarter, waxing gibbous, full moon. That takes about 2 weeks, 14 and 3/4 days, something on that order. Now, starting the day after a full moon, what you would experience is a waning gibbous. When it's a waning phase, now the moon grew from the right, and for a waning gibbous, you're going to start to see that it diminishes from the right edge. So for the waning gibbous, it's greater than 50% illuminated, but now the circular edge is on the right. The only way to really see that well is to flip the diagram over. I'm standing on the Earth. I'm looking up, and now it's the left side where the illumination, this is his left hand, okay, and the left side is illuminated, and there's a little bit of darkness on the right. You flip to 7, you'll notice I have it upside down, but this is the perspective. We're on Earth looking up. You see the left side is lit. Now this is back to 50-50. So for number 7, you would definitely call this the waning quarter. Sometimes people will call this the third quarter or even the last quarter. But if it's a waning phase, it's illuminated on the left, and a quarter phase is definitely going to be 50% illuminated. All right, the last phase that we're seeing here is phase number 8. Okay, the day after the third quarter, the moon is going to continue to get smaller. It's going to appear less illuminated. So the last step here would be a waning crescent. Now, the waning crescent is less than 50 but greater than 0. Almost all of the moon has diminished. There's less and less illumination as seen from Earth. So if I'm shading this in, most of the moon is not lit from Earth's perspective, and there's going to be just a small circular lit edge on the left. So position 8 would be the waning crescent phase. And that's one of the basic diagrams that they will show you. There are some problems with this model. This looks like whenever you have a full moon, the Earth's shadow should fall on the lunar surface. That's not what happens. This diagram can't show you that the moon's orbit is tilted by 5 degrees, so most of the time we miss eclipses. That it's not that common a phenomena for us to observe. It's a lot easier to observe a lunar eclipse than a solar eclipse, but we will get into other diagrams that are going to show you that. But for now, phases of the moon, it's about a month. Okay, the word month comes from the word moon. Okay, they use lunar months originally. So hopefully this helps you to understand these terms. Take care.